everyone, welcome to the project Event Data Pipeline using Spark and ELK on AWS. So, what exactly does an event data pipeline stand for? So, what is event data? So, event data in the name itself is suggests that it has the events which are associated at a certain point of time. Like an event which occurred, suppose an accident is an event, so which occurs at what location, at what time, and what are the details of the trucks which caused the accident. So those kind of information is mainly known as event data. So that kind of event data, which is also some kind of related to log kind of data, so text data. So that data we are going to analyze in this project using a data pipeline and an architecture, how we extract the data, then parse the data, then perform some analysis on data, and then visualize the data. So this is how we are going to see how to build a pipeline using Spark and Elasticsearch. So let's move on to the next slide. So before moving on to what event data analysis is, so let's learn what is big data. So event data is also a kind of a data which will be generated for every second or every interval of time. So which has to be actually stored somewhere, or it has to be captured first, then stored somewhere, and then perform analysis. So that real-time streaming data can be captured at regular intervals of time from millions of IoT devices like sensors, logs, and device APIs. So these kind of real-time streaming data as well as historical data which is present in SQL kind of databases, both can be stored in this distributed system and can be analyzed. So to store these huge volumes of data with high velocity and veracity, so we need an efficient scalable storage system which is distributed across all nodes in either local or in cloud. So that distributed system is a Hadoop. So this concept of Hadoop which can be classified into two groups. So one is storage and another one is processing. So storage will be HDFS, Hadoop Distributed File System, and processing is done using MapReduce. So all the tools and services which are built on top of this MapReduce processing. Suppose Hive processing is built on top of MapReduce. All the queries we run in Hive are MapReduce processing. Underlying will be the MapReduce processing. So initially the process of processing of this data used to be done in Java by writing some MapReduce codes with controller services. So nowadays a lot of tools have been developed on top of MapReduce like Hive, Presto, etc., which can be directly used by their built-in SQL format instead of writing huge codes. So that's quite easier to use. So underlying storage will be the HDFS for everything, even though we want to build a table on top of Hive, or even though we want to do some analysis on it. So we can create a Hive table on top of HDFS data. We can and analyze it. So underlying processing will be the MapReduce. So this is a slight introduction about how the process goes on in big data. And now let's move on to what a data pipeline is. As the name suggests, what is a pipeline? Pipeline is nothing but a thing or a tool which connects from source to destination and which aids in the orchestration of the process, automation of the process. So data pipeline basically refers to a system of moving data from one system to another. So the data may or may not be transformed. It can be directly pushed onto the destination system. It may be processed in real time instead of batches. We can do batch processing or real time processing. So right from extracting or capturing of the data using various tools, storing raw data, cleaning, validation of data, transformation of data into query-worthy format, and visualization. Final thing, all of these things finally go into the visualization layer, in which we can visualize the key performance indicators in the data, whether it can be insurance data, whether it can be network data or banking data or any domain related data. So the final goal is to visualize the trends in the data, how the data is changing according to the time, or how are the values of the metrics changing according to the time. So this is the main feature of a data pipeline, like right from extraction of the data to visualization. So these all the things comes under a data pipeline. So, scalability, reliability, security should be taken into consideration in each of the step of pipeline building using big data environments. So, this scalability is the thing. Once the devices generate millions and millions of rows, suppose an IoT device, for example, is generating some 1 million rows per day. So that data first has to be captured somewhere. So there are data capturing tools such as Nifi, Kafka, and many other APIs. So those APIs will be capturing those data from the IoT devices. Once the APIs get the data, we will actually capture the data from the APIs using tools. Once we capture all these data, we need to store it somewhere, right? So for that storage of this huge data, we need a distributed environment or a storage layer known as Hadoop distributed file system. So this huge data can be stored directly dumped over here, and then tables can be built on top of it, or any other tools can be built on top of it, and then perform either cleaning, transformation of the data, and processing of the data, etc. So the scalability, reliability, and security also should be provided to the data, right? So without the security layer, the data can be hacked easily by the hackers. So the security layer, either SSL or SASL, should be configured while extraction of the data. So also transformed data can be used to derive the key performance indicators and derive initial insights from the data for exploratory analysis. So these transformations in the data, like first initially we get the raw data, right? It can be in any format, like CSV format directly, or JSON format, complex JSON format, or text format, or anything. So these data formats need to be normalized first and then denormalized. So first directly dump the data, then perform cleaning of the data. Cleaning of the data mainly comprises of whether there are any duplicates, or whether there are any null values or any special characters in the data. So these all will be taken care in data cleaning part. So data cleaning can be directly done using Python. Mainly used is Python. Actually, we write a Python code to get the data from HDFS, to fetch the file from HDFS, and then clean the data and write the error files in some other HDFS location. Usually this thing happens in Python. So data cleaning can also happen in Spark. So either in Pyspark also we can do. So there are many other tools with which we can clean the data. So directly UI tools will be there which we can clean the data, and ETL processes can be done using many other tools in the market. So first data cleaning, then data validation. So what is data validation? Data validation is nothing but we need to validate the existing or the incoming data with a specific schema which is already defined. Suppose we have a schema defined for the data which is being pushed into the HDFS. So we need to validate each and every field in the data to fit the given schema. Suppose the data is having extra columns, then it will not fit the schema, right? Suppose the data is not fitting the data type. Suppose there is a date field and we are getting the data in the form of string field. So that is a data anomaly. So in that way, the data validation has to be done. Once the data is validated and cleaned, then we need to build a table on top of it or to perform analysis. If we do not build a table, we can directly pull that into some Pyspark to perform some analysis on top of it, read it into a data frame and do the queries using Pyspark SQL. So there are many other things which can be performed with the raw data. So once we get the raw data, clean it, validate it, and do the analysis on top of it, what is the thing which we are going to achieve? We are going to show some of the KPIs to the end user, which will be useful for their business. So further analysis of data using machine learning algorithms. Once we have the cleaned data, we can also perform initial exploratory analysis kind of things, initial KPIs, and the extension of it is nothing but prediction. The prediction part is nothing but the machine learning algorithms which can be used to derive predictions out of the data, either historical or near real-time data. So this is some of the introduction about the data pipeline. And so why should we build the data pipelines? Are data pipelines really necessary? Do we need to connect the source system and destination system each and every time we want to pull the data, or we need to automate it or orchestrate the data? So mainly we need to orchestrate any data pipeline. We need to schedule the data pipeline to run at a certain interval of time so that it will reduce the manual process. So this automation of the data pipeline has a huge business impact. It saves a lot of hours for actuaries as well as developers. So it saves time and effort for actuaries and business intelligence analysts. So manual process of cleaning, validation, these all if we do for each and every file in local or manually, it's quite tedious process. It will take long hours of time and it's a time waste. So if we automate this process, then we can reduce the time of validation, cleaning and processing very drastically. So automating this simple process saves 3 to 4 hours on an average for each run, for each file. So similarly, automation of ETLs using cron, Uzi, Airflow processes saves effort and time for data engineers as well as analysts. So we have different automation or orchestration tools in the market, mainly cron and as well as Uzi, as well as Apache Airflow, which is widely used in distributed environments for heavy workloads. So we'll discuss about Airflow, cron and Uzi also. So only pipeline monitoring and maintenance need to be taken care of once the pipeline is built. Once we build the pipeline and schedule the pipeline, it will run by itself, right? But we need to monitor whether it is running correctly or it is failing due to some reason. So that monitoring need to be done and maintenance of the pipelines and data centers need to be done. Only that needs to be taken care once the pipeline is built. So grabbing the data from source to destination sources, being APIs, Google Sheets, local systems, SQL based databases, these are different examples of source systems. Destination systems are where we are going to store the data, like HDFS, like destination can be Kafka. We can pull the real-time streaming data from API using Kafka also, Flume, Storm, Logstash to grab the real-time data. So this is some context or throwing some light into big data pipeline. So here are few source and destination systems. So source systems are streaming APIs, SQL databases, Google Sheets, local systems. So data capturing tools are Kafka, Flume, Logstash, Nifi, Storm, Python. So destination systems are HDFS followed by Hive, processing using Pyspark or HiveQL, then Elasticsearch, Druid SQL. These are some of the destination systems. Visualization layer. Visualization layer comprises of many visualization tools in the market. Some few of them which have been gained much recognition are Tableau, Power BI, QuickSight, Kibana, Grafana, ClickView, and Python. So we can also visualize using Python. So these are some of the few source and destination systems.